you tonight?
Good, how about you?
Good. So it looks like we're going to do conic sections tonight.
Yeah, just started that unit today.
Okay. So where would you like to begin? I presume you started with parabolas?
Yeah, that's all we've done so far is parabolas. That's all our homework is.
You haven't done circles or ellipses or hyperbolas, which
Nope,
are
not yet.
the other three conic sections that you will deal with.
Okay.
Okay. Now, parabolas, oddly enough, are treated differently when they're conic sections as opposed to when you just have y equal x squared.
Okay.
In other words, you've been aware of parabolas for a long time. Y equal x squared is this parabola. It's just that you've never learned about the focus or the directrix until now.
Yeah.
Any parabola has a point somewhere there that's the focus, and it has a directrix, which is a invisible line that's an equal distance from the vertex as the focus is.
Okay.
So at this point we're going to study parabolas, look at their focus, look at their directrix, and also examine parabolas that are sideways parabolas. That parabola right there is x equal y squared instead of y equal x squared.
Okay.
Okay. So, let me ask you, what is the standard format that they have given you? Because different school systems use different formats.
Ours is x minus h squared equals 4p parenthesis y minus k.
Okay, good. And I say good. Well, notice how different this is from the normal equation of a parabola. Here's the normal equation of a parabola in vertex format. Okay?
Yeah, dang.
So what they've done is if you solve this equation up here for y, you end up with a equals 1 over 4p. Okay? So they've changed the format. So instead of saying a or 1 over a, they introduced this new variable called p, which is the distance to the focus. In other words, in that picture that I'm drawing, this is p. The distance p right there is the distance from the vertex to that focus. It's also the distance from the vertex to the directrix.
Okay.
Okay? So, okay. We'll work with this format. That's the one I'm most used to, so I kind of like that one. All right. And which problem do we want to start with here?
So we have to do, we should probably start with like 1 through 3. We have to do 1 through 3 and then 7 to 10.
Okay.
So.
X squared equals 6y. Oh, man. Don't tell me. Hold on. My computer screen is frozen. I may end up having to reboot and call you back. Or not call you back, but send you another meeting ID number. Because in the past, I'm completely stuck and frozen here. Hold on a moment. Can you still hear me?
Yeah.
Let me see what happens if I can log out of something here and see if I can end this difficulty. Without having to reboot.
Okay.
Okay, that looks like it might have done it. Yeah, okay. Now let me open my thing up again. Alright. close this out. See if that helps. Reopen it. So far, so good. What was it again? Can you read it to me? The first problem?
X squared equals 6y.
Okay. And our standard is x minus h squared equals 4p times y minus k. So, in this particular instance, for this function, what is h and what is k?
H and k are both 0, right?
Right, and that's the center, or excuse me, that's the vertex of the parabola. So
Okay.
this is a parabola. Well, we know what this parabola looks like. It looks something. Its vertex is at 0, 0. I mean, I could solve it for y. Y is x squared over 6, so it would be a flat parabola like this. But I could solve it using the old techniques we had for doing parabolas. But using the new technique, we know the vertex is there, and the only thing left to discover is where the focus is. Okay? Well, since this has to fit that format, what is 4p equal to?
6.
So p equals 3 halves. So we're looking at a parabola whose focus is at 0, 3 halves.
Okay.
And whose directrix is at y equal minus 3 halves. They want the vertex, the focus, the directrix, and the focal width. Well, the focal width is that distance right there. And that is always 2 times p.
I thought it was 4p, the absolute value of 4p.
You know what, you might be right. Excuse me. Hold on a second. Yes, sorry.
Oh, that's okay.
So the focal width is 6. Yeah, I was looking at the book. I overlooked it. Okay, so that's essentially what we're going to do to every equation here. Now, let's list the sideways parabolas, which is going to be y minus k squared equals 4p times x minus h. Okay, so if we have a function, and the thing to really check for is whether you have x squared or y squared.
Okay.
What's the second function? Y squared equals minus 8x. Gosh, I'm feeling good because this is one of the few times I've ever recovered from that problem without having, it is. I can count on one hand. I've had that problem. It hits about once a week, and I've never been able to recover from it without rebooting my computer and restarting the GoToMeeting.
Well, dang, that's good.
Yeah, tonight was great.
Yeah.
Okay, so this one fits this second format. So what is the vertex of this one?
0, 0.
And the focus?
The focus would be negative. Focus would be -2.
Yeah.
Oh wait, -2. So, yeah, -2.
Okay. And we know we're looking at a graph that is a horizontal parabola. Does it open to the right or does it open to the left?
The left.
Right. In other words, if I solve this for x, like we typically would, we would have x equal minus y squared over 8. And that minus sign, just like that minus sign in a vertical parabola means that it opens down instead of up, well, the minus sign in a horizontal parabola means it opens to the left instead of to the right. And
Okay.
the focus, meaning the minus 2, well, I would have to go to the left, and that makes sense, right? The focus should be minus. What's the equation of the directrix?
2.
X equal 2.
Yeah.
In other words, it's the directrix is always the equation of a line. So it's not just 2. It's x equal 2, or with a vertical parabola, it's y equals some number. Okay?
Okay.
And then the focal length, or focal width, I guess. Yeah, the focal length is actually p. In other words, this distance here is the focal length, and this distance here, which is 4 times the focal length, is 4 times the absolute value of the focus, so that would be 8.
Okay.
Okay. All right, let's get harder ones here. 3. Y minus 2 squared equals 4 times x plus 3. Y minus 2 squared equals 4 times x plus 3. What kind of a parabola are we looking at?
It would be sideways to the right.
Okay. And so we would, well, where's the vertex?
The vertex is 3, negative 2.
Yeah.
Right?
No, it's negative 3, positive 2.
Oh, yeah, because the plus and the minus signs. Okay.
Right. In other words, until you get to calculus, you're always going to be looking at x minus h's and y minus k's. And that's true whether you're talking parabolas, whether you're talking circles, whether you're talking ellipses, whether you're talking hyperbolas. They all are x minus h's and y minus k's. Okay? Not going to be till you get to calculus where you have to deal again with an x plus h. So just remember that the standard is always minus, which means that y minus 2, k must be plus 2. And k is the y coordinate of the vertex. And x plus 3, h must be minus 3.
Okay.
Okay, because it's x minus h. So looking at an x plus 3, h has to be minus 3. Okay, and the focus? I should say the focus, let's see, this is the width, this is the length. The focal length.
Okay, so the focus would be at 3, negative 3.
Well, what's the focal length?
1.
Okay, good. So we're looking at a parabola that opens to the right, has its vertex right here. So it looks something like this. So to figure out, you know that distance is 1. So what did you say?
3, negative 3.
Yeah, hold on. I graphed this thing wrong. In other words, the vertex is at minus 3, 2, which is up here. And it opens to the right. So the focus has to be to the right. Where's the focus again?
Wait, wasn't the vertex? Oh, never mind. I graphed it wrong too. Oops.
That's okay. And
this
this focal length, in other words, coming up with a positive p, means we start at the vertex and we go to the right. If you come up with a negative P, you start at the vertex and you go left. Or
Okay.
if it's vertical, you start at the vertex and go down. If it's negative, you go up if it's positive. So what are the coordinates on this focus?
On that one would be -2, 2.
Okay, good. And the focal width is 4. Okay. You said 1, 2, and 3 only?
Yeah, and then we do, the next ones are 7 through 10.
Okay. Let's see. So we're matching the equations with the... Okay, so x squared equals 3y. Which one is that?
That opens up.
There's only one there that opens up. C. 8. X squared equals -4y.
Opens down, so B.
Okay. Y squared equals -5x.
That opens to the left, so A.
And finally, y squared equals 10x.
D.
Okay. What next?
The next ones we have to do, let me look, are 21 through 35 odd. Just the odd ones.
Okay. So here they're giving us the focus. Hold on. And the vertex. So the vertex is -4, -4. The focus is at -2, -4. So that should allow us to figure out P.
Okay.
Okay, hold on a moment. So, first of all, if my vertex, here, let's draw a little picture of this. My vertex is right there, right? -4, -4. My
Yeah.
focus is -2, -4. Right there. What kind of a parabola am I looking at?
That would be a Y, like a Y squared, so it would open to the right.
It opens to the right. In other words, I know with certainty, just from this information, that this is what I'm looking at. So I'm going to use the formula, the second one.
Okay.
There we go. So I'm going to use this one. What is my P?
Wouldn't P be 8? I mean, P would be 2.
P would be 2. Okay. So I am ready to write my equation. I'm going to write it exactly like that. And it's going to be what?
Y plus 4 squared equal 8 parenthesis x plus 4.
Good. Okay. 22 is the same as 21, so that's why you're doing odd only.
Yep.
Let's look at 23. So 23 has a focus at 3, 4, and it has a directrix of y equals 1. What kind of parabola are we looking at here?
It would open up.
And
It would be x
where would
squared.
its vertex be?
2, 4. I mean, sorry.
You know the vertex is halfway between the y coordinate and the directrix, right?
Yeah.
Okay, so what's the coordinates of this vertex?
The coordinates would be 3, 2.
Not 2, but how about 2.5?
Oh yeah, 2.5. Okay.
2.5 is 1.5 away from 4, and it is 1.5 away from this line, 1. So we know we're looking at a parabola like this. Our vertex looks right, our directrix looks right, we've got the vertex, so we need the equation. And we're talking the top equation format. So what's the equation?
X minus 3 squared equals 4 parenthesis y minus 2 and 1/2.
What's the focal length?
It's 1 and 1/2.
Okay, so what goes here? What's 4p?
6.
Okay, and now y minus 4. In other words, once you know the vertex, you have 90% of the equation. The only thing you need is the focal length. In other words, this distance right here. Once you have the vertex and that focal length, you're ready to write the equation. That's all you need.
Okay.
Okay. So let's look at 25. Vertex is at 4, 3. The directrix is at x equals 6.
So it's opening down. Oh wait, x equals 6, so it's opening to the left, so it's a y. 1.
Okay. This is at 6. What's the vertex?
The vertex would be...
Or actually, the easiest thing to start with is P. What is P?
P is...
What are the what is the length of P? What's the focal length? In other words, what's this right here?
Would it be 2?
Well, we're going from 4 to 6, which is 2 focal lengths. So the focal length has to be 1. In other words, this coordinate to this point right there have to be 5, 3.
Okay.
See why? In other words, the coordinates, let me write it so that it's not written right on top of the vertex. That's a little confusing. So the vertex is right here. So this is 4 right there. This is 6 over there.
Isn't the vertex where it goes through, not the...
The vertex is between the focus and the directrix. Exactly.
Yeah. So you drew it out too far, I think. Wouldn't 4 be back where the parabola starts?
Well, what they gave us was the vertex. Oh, excuse me. I apologize totally. For some reason, I was thinking they gave us the focus. That was problem 23. Yeah, you're absolutely right. The vertex is 4, 3. And if the directrix is at x equals 6, then this P is 2. So P has to be back here at what?
2.
We don't even need the coordinates of P. I mean, we don't need the coordinates of the focus. Excuse me. Once we get the coordinates of the vertex, what are the coordinates of the vertex?
4, 3.
So, and we're using the second formula. So we have y minus 3 equals, what's P?
P is 2,
4P.
but it So wouldn't it be -8 because it opens to the left?
Yes, and in fact, if you want to look at it, P is actually -2 because P is the measurement from the vertex to the focus, and I have to go to the left. So P is -2, so I get -8 times x minus 4.
Okay.
And this one here is squared.
Okay.
Okay. All right. I'm sorry, I didn't see that word vertex. I was thinking it was focus.
No, it's okay.
What next? 27? Okay. Let's do it this way. Let's put our vertex on there. It's at 2 minus 1 right there. Opens upward, has a focal width of 16. So whatever our focus is, this distance here is 16. What does that make this distance there, the vertical distance?
4.
Okay. So that makes P equal to 4. That's all we need. What's our equation?
X minus 2 squared equals 16 y minus plus 1.
You got it.
Cool.
And there are so many different things they can give you. In other words, they can give you 2 pieces or 3 pieces of information that allow you to calculate everything. And that's what they're doing. So, this one, our vertex is at -1 minus 4. Opens to the left. Focal width of 10. What is P?
10 divided by 4.
Okay, that's fine. 10 divided by 4, and we can leave it like that. We don't need to simplify it because notice that we're going to write it as an equation with 4P. And is it positive or negative?
Negative.
Okay. So my equation is what?
Y plus 4 squared equals -10 parenthesis x plus 1.
There you go.
Cool.
31 next. 31, 33, and 35?
Yeah.
I see them circled. Does that mean those are the ones you have?
Someone else circled them in my book. I'm not sure.
Okay. Or do you need to do these 3?
I think I got it.
Okay. You know how to graph those? Just tell me what that is. Is it sideways? Which way does it open?
It opens to the left.
Okay. Which way does this one open?
Down.
And this one?
To the right.
Okay. What next? You want to? You graphing them using a function grapher? You have any problems with that?
No. And I don't think we have to do those. I think that's the end of our homework.
Okay. And your calc, oh, okay, yeah, I'm sorry. We've actually gone over the time. I didn't realize it. Okay. So you're good to go?
Yeah, I'm good.
All right, Aspen. I will talk to you next Monday.
All right, sounds good. Thanks so much.